In this video, we're going to look at how to simplify surds, and in doing so, we'll cover some of the rules you need to know about how to manipulate them. First, though, we need to cover what a surd is. In technical terms, a surd is an irrational root of a rational number, but all this really means is that they have a square root sign with a number inside that you can't easily square root because it's not a square number, so all of these terms here are surds because 5, 40, and 27 aren't square numbers. This means that if you put any of these into your calculator, you would get an answer with loads of decimal places, which would theoretically go on forever, whereas if we had the square root of 9 or the square root of 36, these numbers don't count as surds because 9 and 36 are both square numbers, with root 9 being 3 and root 36 being 6. One thing that really helps with simplifying surds is knowing all of your square numbers, so if you don't already know all of these square numbers, then it's definitely worth learning them all before you try and do this topic. The other thing that you need to know before you can simplify surds is how they multiply. If we took the square root of 3 and multiplied it by the square root of 5, then that's exactly the same thing as the square root of 3 times 5, or the square root of 15. This means that we can also go the opposite way and divide one surd into two. For example, if we took root 40, we could rewrite it as a product of any of its factor pairs. For example, root 1 times root 40, root 2 times root 20, root 4 times root 10, or root 5 times root 8. One important point, though, is that this rule only works if you're multiplying or dividing. So while you could rewrite root 40 as root 80 divided by root 2 because 40 equals 80 divided by 2, you can't write it as root 30 plus root 10 or root 60 minus root 20 because even though 30 plus 10 and 60 minus 20 are both 40, we can only use this rule when we're multiplying or dividing, not when we're adding or subtracting. Back to writing them as the product of their factor pairs, though, the benefit of doing this is that sometimes one of these factor pairs will contain a square number, like this one here, which has a root 4. Because 4 is a square number, we can simplify the root 4 to a 2 so that it becomes 2 times root 10, which we write as 2 root 10, so 2 root 10 is a simplified version of square root 40, and that's all we need to do to simplify a surd. Let's try the same thing for these surds. So for the square root of 27, we need to find a factor pair of 27 that contains a square number, and if you don't just know it off the top of your head, you're going to write out all the factors as root 1 times root 27 and root 3 times root 9. Root 1 times the original number is never going to help though, so we can cross this one out. The thing to spot is that the 9 here is a square number, so we can rewrite the root 9 as a 3 to get root 3 times 3, then swap them around to get 3 times root 3, and then just write that as 3 root 3 as our final answer. For the square root of 200, it would take ages to write out all the factor pairs, so you really just need to be able to notice that 100 is both a factor and a square number. In this case, there are actually a whole bunch of other factors that are square numbers as well, like 4 and 25, but importantly, 100 is the biggest one, and you always want to go for the biggest square factor. You can still get the right answer if you pick a smaller one, but you'll just have to do a few more steps. So if we go for 100, we'd have to times it by 2 to make 200. So we can rewrite root 200 as root 100 times root 2, which simplifies to 10 root 2, because the square root of 100 is 10. For root 48, the easiest way to do it is notice that it's equal to root 16 times root 3, which we can simplify to 4 times root 3, or just 4 root 3. Anyway, that's everything for this video, so hope you found it useful. If you did, then please do give us a like and subscribe, and cheers for watching.